The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Very simple. So let's do number 2, or example number 2 on this page. As you can see, another very interesting structure. The hydroxyl group will obviously be the highest priority functional group. Some naming beginning from left. So naming would begin from left to right. And that would give us, so naming in this case would begin from left to right, which gives us 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So we have 9 carbon atoms in the parent chain of this molecule, and the highest priority functional group, which is a hydroxyl group, is in carbon number 3. And we have 2 substituents, 2 chlorine atoms in carbon number 4, and we also have a 2 carbon substituent, so an ethyl group on carbon number 6. Okay, so the parent chain name would be nonane, because there are 9 carbons. Drop the E and add all, you get nonanol. Identify the location of the hydroxyl group. It's in carbon number 3, so that'd be nonan3-ol, and add the substituents as a prefix in the name of that compound. So what do we have in this case? 4, 4. So it's 4, 4 because there's 2 chlorines in carbon number 4, and you must say dichloro, indicating 2. So di for 2. 6, indicating the position of the ethyl substituent, and finally the parent name, which becomes nonan3-ol. Okay, so it might seem complicated putting all that information together, but if you approach the problems in a very systematic way, you're never going to have a problem. All we did was identify the parent chain, okay, the highest priority functional group, which was that hydroxyl group right there. So we know it's an alcohol. It's a 9-carbon chain alcohol with 3 substituents. So 2 chlorine atoms and 1 ethyl group located at position number 4 and 6 respectively. So it's not that hard. Let's move on and do number 3 at the bottom of the screen right there. So number 3 is an interesting example. Again, this might be new to some of you. We have a hydroxyl group, okay, bound to an aromatic ring. Okay, so whenever you have a compound of this kind or of this structure, the aromatic ring is treated as a phenyl group. So it's treated as a phenyl group. I want you to remember that. So all you're going to do in this case is you are going to identify the substituent containing the hydroxyl group. So you have hydroxyl group right there. You have 1 carbon. Okay, so if that was an alcohol on its own, that would be methanol. And then all you are going to do after that is add the word or the name phenyl and the prefix of that name, and there you have it, the name of your compound. So this very simply becomes phenyl, identifying the aromatic ring, methanol. Identifying that alcoholic substituent that has 1 carbon atom right there. Okay, so the name of that compound becomes phenylmethanol. I'm going to give you its common name as well. The common name of this compound would be benzyl alcohol. Okay, wouldn't hurt you to know this. You might encounter it in literature. It becomes benzyl alcohol. So let's move on. Let's do number 4, bottom right of the screen right there.